Hello everyone. Now I will do another PVT design using PVT Designer of T-Navigator. So as usual, here we go to new. Okay, we will create a new project for this tutorial. Okay, so I created a new project. Okay, I create a new folder and I want to store the project file into that folder. I will call it Condensate. Okay, because I want to create a condensate model in this exercise. Okay, so we will wait. Okay, hopefully we can create a good model. All right. Okay, press this one if you want to close the message. Okay, so this is our working window. I will check my component first. So this is my component. You see I have CO2, I have this should be nitrogen, and then I have C1, C2, C3, ISO C4, normal C4, C5, and C6, and then C7 plus. Okay, the initial pressure is 2210. Initial temperature, assuming an isothermal condition, the temperature is 209. Okay, so go to add library component, click open, and then I will select go down the non-hydrocarbon. I will add nitrogen and CO2. Okay, and then I will select from C1 down to C6 from the library components. Okay, all right. Now I will create C7 plus as my user component. Okay, click this one, add user components, and then I will call it C7 plus. And by the way, I need to check the molecular weight and then specific gravity. Okay, let me search for the data for a while. Okay, so the molecular weight is 123 in kilogram. What is this? This is molecular weight. So this is the kilogram per kilomole. And then this one, 7485. Okay, so I will click OK. All right. And then, of course, we need to input the composition. The composition is in mole percent. So let's go to mole percent. Okay, and then the first component is nitrogen. So I will change this one. Okay, and then the second one is CO2. Okay, wait a minute. All right, if you sum them up, this is 100%. So yeah, I will copy, make sure that it is ISO first and then normal, ISO first and then normal. Okay, ISO normal, ISO normal. Okay, so I will paste my data here, and the summation of all the fractions is 100%. C7 plus is 0.96. Okay, and then you can see the critical temperature and critical pressure, eccentric factor, molecular weight of the library components. We can be sure that all of these numbers are correct because it is library components. But C7 plus, we just input the molecular weight and then we just input the specific gravity, and the critical temperature, critical pressure will be calculated by the PVT designer. So there maybe there is still uncertainty, and that's why we need to use that. We need to perform matching by adjusting C7 plus. Okay, so that's the game plan. But first, I want to go to, yeah, I've saved it. I want to go to the saturation pressure. Okay, tab name, saturation pressure, and I want to change the unit first, by the way. I prefer field unit. Okay, so the pressure will be in PSIA. Okay, and then plus click plus this one, and then experiments saturation pressure. Okay, number of values, stage, okay, and then for the minimum I want to start from minus 200 degrees Fahrenheit, maximum, okay, and then calculate critical temperature, click OK. Okay, all right, so this one is the, all right, the bubble point pressure and then dew point pressure. Of course, this result is just estimation. Okay, we need to perform matching with the actual data from the library. Okay, this is the table, temperature, and then the pressure. Okay, all right. Now go to samples and then click this one, saturation pressure, create saturation pressure. And yeah, we need to provide the bubble point pressure or the dew point pressure, or both of them if we have for this condensate reservoir. Let me check my data, by the way. Okay. Okay, so I have the data for dew point pressure. This is 209, and the dew point pressure is 2210, which is the initial pressure and then the initial temperature. Okay. Make sure you save it. So this is our data. And then let's go to compositional variant. And then, okay. Anyway, go to experiments or phase envelope. Now we will create the phase envelope. Initial temperature from minus 200. If you want, you can generate the hydrate curve, but no need for that. Yeah, later on we can do another phase envelope calculation. So click OK. All right. Okay, so this is the current phase envelope. Okay, of course we can change the setting, not this one, but this one. Let's say you want to change this one. You can change the size of that. Okay, and then if you want to change the color, just click this one. You can change to red and or to other color, but I prefer yellow. Okay, and I prefer all the settings. If you want to generate the table, okay, this is, what is this? Show hydrate table, but no, I haven't generated. So yeah, I think we can, at this time, we can use this phase envelope. Okay, if you check, uncheck, dew point will shows up. Dew point, the border between the gas phase and then the liquid, and then the bubble point is this is the border, okay, from the pure liquid and then the time where we have bubbles of gas. Okay, and then yeah, click this one. Okay, touch this button. You see originally the data, the saturation pressure data actually is located here. So it's still not match. And of course, we will perform matching. Yeah, by the way, I'm still trying to find the best match. So not yet. So I just want to make the weight higher so that I can achieve very good matching for the saturation pressure. Okay, here we can say it's match, but the gassy factor is not, it's not very good. Okay, for this one, liquid dropout, not very good. Yeah, so it's quite challenging to find the best match. Okay, at some point we have to say that we are satisfied. But by the way, what what happened if we change to software Wong? Again, I want to use C7 plus for matching, and then this one for matching. Okay, and then let's see if we can achieve better matching with software Wong. Hopefully saturation pressure doesn't match. Gassy factor, no, although it becomes closer. Software Wong relative volume, not very good. But actually, the base case, the recommendation is to use Peng Robinson. So yeah, this is the exercise that we need to do, or maybe change the omega A from nitrogen, CO2, and in addition to C1, C2, and C3. Okay, wait, C1, C2, and then C3. Okay, I want to use them for matching. Okay. Let's see, relative volume for just increase the weight and expect that the matching can be better. Maybe at some point we have to be satisfied because we cannot achieve perfect match for all the parameters: saturation pressure, Z factor, relative volume, liquid dropout. Okay, let's see the dew point pressure. Okay, the gassy factor. We are going farther. Relative volume, liquid dropout. Liquid dropout is good, but okay, gassy factor is not very good. Gassy factor is very important though. So what if we increase the weight for CCE to 10, just in case, and then to make the calculation faster, but to be more detailed. Okay, what happened? Not very good. Not very good. Yeah. So maybe that's the best we can do. At some point, yeah, maybe we need to change this one, min, max, best value, but of course it will be more challenging. So let's say I will close composition. Let's say I go back to here and then face envelope for this one. Why is shaped like this? Hmm, it's weird. Hmm, something wrong for the face envelope. Saturation pressure. It's weird though. It's totally wrong. Don't know why. CVD looks good, but face envelope cannot be like this. Yes. Also cannot be like this. Okay, this is more makes sense. All right. Or maybe I should remove this one or this one and then just do another matching. This one. Okay, and then let's say I want to use C1, C2, C3, including CO2 in the matching process. Let's go to the matching, and then I want to include this one, 111. Yeah, almost match. Gassy factor. Okay. Yeah, I think yeah the liquid dropout is quite good. It's quite important because based on the production we have liquid production, actually we have oil, so maybe yeah we can accept this one gassy factor. So matching variant we save. Okay, close, and then let's go here, check the saturation pressure. No, it looks like this. It's weird. Face envelope. Oh no. Oh, something happened. Let's open. Okay. Hmm. Not yet saved. Very good. I'm gonna remove this one. I just want to try. Weird. Okay, by the way, that's the way we try to achieve matching in our PVT model. Okay. Yeah, let me try to build another model, but yeah, at least so far you know the workflow, how to do PVT modeling and PVT designer. Okay, I will see you later. Okay, thank you.